So let me share my screen. So we are going to design this circuit. Let me bring this circuit here. So this is the circuit. So basically we are going to design a raindrop tracking PCB. So the PCB, so the circuit is over here. So before we are going to design a PCB, first we need to scratch the circuit. We need to make the schematic on paper, and maybe if you, we can also test the circuit on the breadboard before going to design a PCB. Then that will be really helpful. So here we are using 3-volt battery. So in PCB, we are going to put the battery case over here. So the battery case is CR2032BS61. And we are using two BGT bipolar junction transistor. So the one channel 1 Q1 is 2N2907. Here I have made mistake over here. 0 should be between 9 and 7. And we are going to use another channel Q2, which is 2N2222A. So this is N type and this is P type, PNP transistor, and this is NPN transistor. And so this is booster. This is booster, and this one, the name HMB12 7512B. So this is the booster. And we are also going to use one capacitor of 10 nanofarad for biasing and one resistor of 10K. And this is variable resistor, which is 330 kilo ohm. And we are going to use a raindrop sensor, RSB. So basically the raindrop sensor is like electrode, like it has 2 electrode and it has plate. So when the rain drops on this strip, then there will be like current moving from over there, from here to turn on this transistor, and this transistor is directly connected to here, the base of channel Q1. So both transistor they will be turn on and turn off because of the sensing the current from the plate. And here this one is, so basically this is just variable resistor over here. So by the raindrop, the resistance is changing. So I'm going to show you the working mechanism of the sensor. I have this one data over here. So here, so this circuit and this circuit is quite similar, but what I'm gonna use, which is like more complicated than this one, this is like more general circuit, and both have like mostly like same working mechanism. So we are going to use a rain sensor circuit. I mean, this is the rain sensor, and we are going to use the booster, which is just like an alarm. And here they use 9 volt, but we are going to use just 3 volt. So here, so in this circuit, they use different transistor. So essential for component for switching. And the rain sensor is very responsible to water drops, they are saying. So basically the sensor senses the rain, and then after the transistor act as a switch, and there will be like a current flowing in milliamperes in this circuit in here. So raindrop when raindrop falls on this strip, and this electrode is connected directly to over here to the positive terminal of the battery, and this one is connected to the base of channel 2, and from here we have resistor R1 and C1 capacitor. Here is the ground. Maybe we can take a look for the data for the, so this is 2N907A silicon PNP transistor. So this is basically used for a small signal switching. So there will be like a current in milliampere. So here the data sheet for this transistor. Like basically the current will be in milliampere. And I have also like another one. Yeah. Here. So this one is another channel Q2, which is 2N222A. So this is high speed switches. So here is the layout. So we are going to use this one, TO18. What do I have here? Yeah. So this is another thing. This is for the battery case. Yeah, here it has like plus and minus terminal, and basically we are going to use 2-cell battery, like 1.5 volt each one. So total 3 volt in series. So we are going to build this circuit in PCB schematic. So I already built this circuit. I built this circuit last night. So, and I'm going to build this circuit one more time. For now, just quick recovery, like what we are going to do in this video. So here we have like R2 330 kilo ohm, and the one electrode is going to the base of channel 2, and from here it's biasing. It's connected 10K R1 and C1 10 nanofarad to here, and this is the booster. So when rain drops on this sensor, then there will be like current, a small current flow over here, and it turn on this transistor, and after that this transistor will be turned on, then the booster will be alarmed, like just booping sound. And I have already the PCB also here. So here the PCB. So now I'm going to show you as a 3D view. So this is the upper layer, we can see this is the bottom layer. So this one is booger, plus terminal, minus terminal. This is the ground, and this is channel 1, channel 2. This is channel 2. This is connected to the base. Is connected to the terminal 1, the electrode 1 or terminal 1 of on the sensor, and this guy is basically ground. So emitter for the channel 2 is grounded, and here is the capacitor. This is connected to the Q1, and this one is connected to R1, R12. This is the R12 side, and this guy is connected to here, and we have R2. This part is connected to Q1, and Q1. This one emitter is connected to positive terminal, and this is coming over here, the base. This is the collector, and collector current is going through the booger. So now we're going to look at 3D view. So the 3D view is over here. So this is the booger. This is channel 2. This is channel 1. This is capacitor C1. This is R1. This is R2. This is sensor U1. And this is the battery case. So here basically we can use two cell battery over here, like 2 AA battery. So for the other layer, we can just look it over like this. So these are like silk layer, silk bottom layer. So we can name anything like as a text. Okay. So now we are going to start from a scratch. We are going to build this, and we are going to come over here. Our final design will be like this. So now I'm going to start from here for new project. So for new title, I'm going to write rain sensor 2, and the path will be this one. Description, you can write rain drop tracking PCB design. So now it will be saved. So here the PCB scratch. Here we can make the schematic. To make now we need to choose the parts. So here, so this is design manager. This is common library. This is the library, like common library. When you place this one, it gives you like common values. To use the library, we need to go over here. So this is easy EDA, and this is the company through which we are going to order the parts. So LCSC, this is based on Chinese company, and type symbol, class workplace, LCSC, and this will be assembled in GLC PCB system. Follow like last time I choose this one, raindrop RSB copy. So right now I'm going to place this one on the schematic. We can just click on this one. Before that, I'm going to show you this is the schematic layout and this is the PCB layout footprint for that sensor. So now I'm going to place over here. To round this one, just we need to just press R. So we can round over here. We are going to build same circuit. Now we have already got this one. We need other component. Now we are going to check the channel 1, 2, and 2907A and search. So here we have two same like same 2N2907. We can use any of those. First, try this one. We need to have like some kind of PCB footprint. Let's try this one. Yeah, it has like this type of footprint. I'm going to choose this one. So now to place this one, we can just place. I'm going to put this guy over here. This is channel 1. Now I'm going to source channel 2. To source channel 2, we don't need to do more. We can just use 2N port 2A. This is NPN transistor. And it has also like same. For here we don't have manufacturer. Let's try over here. It doesn't have any manufacturer, so no, it has manufacturer. This is the manufacturer name, not manufacturer. So I'm going to use same one, the top one. Yes. I'm going to put right over here. Now I'm going to search the booger. So the booger is HM B12 75 12B. Let's try this one. Yeah, here the booger. Here the booger, and it has also. This is the footprint on the PCB. This is the actual component, and this is the schematic component. So now I'm going to choose this guy. So the booger, we can just leave this one. For now, we can just put over here. So we got booger. Now I'm going to source the battery case. The battery case over here. So the battery case, the brand is CR2032 BS61. Here, manufacturer is Q&J. So this is the PCB schematic. This is the actual one. And this guy, we are going to use this guy. Like when you look at this one, this is the actual one, the 1 and 2. This is theirs. We don't need this one right now. So we can place this one similarly. That one. Or maybe we can do clone. Search one more time. Right. And the battery one. Then just we are going to put over here. This one. Now looks better. Right? So we can put over here if you want. So now we need 3 more components, like 2 resistor and 1 capacitor, 1 ground maybe. So now I'm going to find the resistor 1. So to find a resistor, we can go over here, right over here, or you can just, if you don't want to scroll down, just use this one searching tool and type resistor, and resistor comes. Here is the resistor. It's come. Like this. I'm going to use resistor. Try different resistor. Last time I used a thin film resistor. So they have 20. They don't have. You can use this one if you want to use this one. This this, this is other thing. Let's try this one film capacitor. We need this guy 10 nanofarad. We are going to use this guy. So this should be over here. And here we go. Here we can start this. We need 10K. And we need this guy. White filter. So these are showing like out of stock. Let's try another one. 331. They don't have part over here. We can use from over here. So we can use this one. So this will be R1. Now we also need one more, R2. Is 340K. So sometime we need to go over here like system. If you follow somebody, then it comes over here. Otherwise, there are like a lot of user. Like over here, I am user RAM, and just like here, like most of the time we are just looking for this company LCSC. Like sometimes they have like JLC PCB. Like here they have also like they have a lot of over here. We can try this one. Just rotate this one and we can be right over here. Now we just need to connect the wire, to connect each component with wire. This is done. And we can connect this capacitor over here. That is not correct. So we can go back over here. Save the wire. But here we can connect. Okay, this guy too over here. So here we can connect this one. Like here, we can put right here this one. Then we can connect this guy too. Maybe we can let me remove this guy. Maybe it doesn't look good. It doesn't look good. Maybe we can just displace this one by some over here. Oh, maybe we can displace more. Like this. We can connect this guy. The circuit is mostly done. Now we need to put one of the ground over here. So the schematic is now complete, where we can just zoom, see how it looks. So this is the battery case, this is the buzzer, this is the channel 1, this is channel 2, this is ground, C1, and this is the resistor. Maybe we can change this guy. I think this is U2. Let me go over here. क्या बस फिर तीन क्या बस फिर From here, we can choose the 10 nanofarad here. So here they don't have anything. So we are going to just from easy idea. Where is film capsule? Yeah, they have 10 nanofarad. We can use this one. Yeah, it's same. So it doesn't matter. Like we can keep this one. So everything is now done. So now we are going to convert this one into PCB. Before doing that, we need to save this one. So now it's saved. Now we can convert this one. So I mean they recommended this dimension. So now we are going to just keep this recommendation. So here everything is over here. I don't have mouse, that's why it's giving problem. If you have mouse, then it will be more easier. So now we are going to put each component one by one. So this is the battery case. To flip this one, we are going to use this one, or maybe we can just type R. Yeah, now it's better. We are going to put over here, right over here. Then we are going to put the boozer. Maybe we can put boozer if you want. Right over here, boozer. So this is boozer. We can put Q1, Q2 channel 2 right over here. Q channel. Then we can put this guy, sensor. For now, we can keep over here. We can flip this one. We can keep like this. So we need to keep the sensor as close to the circuit for better for better sensing. So now we are going to put Q1. So let's put Q1 for now over here. For now, we are just removing this guy. Q1 here. We can move this guy over here. Maybe we can move this guy over. That's better. Q1 is over here, boozer over here. Now we are going to put RO U2. The capacitor by over here for now. We can put 10 over here. This is really big. So now R2 is left. R2 we can put No, we can flip this guy. Let me flip this one. R2 maybe we can put R2 over here. This is very big. This one. Maybe we can flip this guy. Now makes more sense. Go. Let's flip this one. If you want, you can keep like this. Otherwise, if you want to change more, you can change more. So this is the register coming over here. And this should be enough. So everything looks good. Now we can go over here for auto rotate. Maybe you can choose the design rule. So the design rule is track width is in these are in millimeter 0.254, and the current length is like 0.152, by diameter 0.61, by drill diameter 0.305. Track length you can put like minimum than the desired law. I'm just following this back. Let me go back one more time. Design rule. I'm going to check these lines. Run this one. So yes, this one is now done. So if you wanna make bigger one, like bigger traces, the copper traces, then we need to change some design rule, like track width we can do. Let's try 0.45. Then run this one. Now it's more clear, like see. So this one is top layer, and we also need one ground. So for ground as a bottom layer, now we are clicking this one, we are checking the bottom layer, this part, and we are going to use the PCB tools, the copper area. So this is this one for ground. So we can put one of the corner, and we can go over here. So you can see there is like blue line. And we can go over here. So here we can right click. Hold on. Hold on. No, I'm going to come back. copper area, ground. Then we can click at the one of the corner. Keep going, like over here. And then something. No, we don't need this. One more time. Copper area. Here we are going to right click. You see, I made a mistake because I need to go over here. Bottom layer. We can use copper wire. I don't have mouse, that's why it's giving me problem. So there is blue line. Let me rotate one more time. For bottom layer, I'm going to use copper area. This doesn't go even. You see, I made a mistake over here. That's why it's giving just partial. But we are not going to use this one. So for this section, we need to be very careful. If you have a mouse, then it will be much easier, I think. If you don't have mouse, then still I feel like over here, no. Here we need, yeah, this time is coming. Yeah, sorry for that. So our PCB is ready now. It's ready now. So here now we are going to test this one. Let's check DRC. So here the DRC errors we got 0. It means our design is perfect. So here, if you want to write something over here, so this one is bottom layer, and it has ground over here. Now this is common ground over here for the booster. This guy, channel 1, this is U11. This is grounded, the emitter is grounded over here. This guy, the anode 1, going to register 1, and also it's going to register 1, U11, and it should go over here, I think. This one be base, from base, I think, you see, the base, it's going over here. It's going to R2. Now I'm going to write something over here. If you want to write anything, this is bottom. So now I'm going to use the bottom silk layer to write something. To write something, we need to use PCB tools. Here is text. We can put anywhere. Anywhere, I mean, not on the copper traces, but we can put on the silk surface. So over here, we need to double, we are here, text. Here it comes text. Now I'm going to write rain drop track tracking PCB. I think we're done. You see? So now it comes over here. We have a small space over here, so we can put right over here. Like that. Now we are going to look this PCB as a 3D view. So this is what we design over here. So this is the top layer. The PCB board thickness is almost, the board thickness is 1.6 millimeter. Suppose for design, if we need like 1 millimeter, then we are going to use just 1 millimeter. So now it's thinner. So layer distance is 0 millimeter. If you wanna add the layer distance, suppose let's try, I mean 0.05. So this is the layer distance, 0.05, and this is the PCB color is blue. We can change in as our wish. So now it's in green. If your favorite color is red, then you can choose red. So surface trim is gold, or maybe if you want to see silver, now it's silver color. If you want to use gold, it's gold. So 3D view, top silk layer. These are silk layer. We don't have any text over here, but we do have text in the background. So here we have text raindrop tracking PCB. So these are the channel. This one is, I believe this one is channel 1, and this is connected to over here. This one is battery. This is the bottom layer. So this is our PCB. This is booster 1. This is channel 2. This is R1 10K. This is capacitor 10 nano. This is channel 1. This is R2. This one is sensor, and this one is battery pack. Now I'm going to show you the last one. I mean, I have already built one. So this one I have already built one. I built this PCB I designed last night. So thickness is really high. I mean, it's 1.6. It's not good for good design. So I'm going to change the thickness like 0.75 millimeter. Maybe I can change the color. Yellow. I don't like yellow color. Maybe green. They have also purple. They have black. So black PCB. So here, this circuit is completed now. So let's go to here the circuit. So we have already designed the board, which is here. Now I'm going to show you how to convert this one into the Gerber file. For this one, BOM, please save your file before export. So first we need to save this one. Yeah, this PCB design is already saved. Now we can look around BOM. So these are basically the order one. So these are the prices. So these all are LCSC part 1. Like, so one click, if you want to order, you can just click over here. Bill of material. So BOM is nothing but it's bill of material. Just like in Walmart, our receipt. Let's click over here. Let's check over here. I'm not going to order, but it's like I need to sign up over here. I'll upload it. Site. I'll upload no data available. So this is just that one. Now I'm going to just cancel this one because I'm not going to order. So we can see over here the whole prices. I think it's less than maybe like $1. I think 0.1 10 16 cent, less than 1 cent, 5 cent. It's like 0.5 cent. So we are not going to see over here. I'm going to convert this one in Gerber file. Just check the DRC. So we checked the DRC, we got no error. So PC price is like 4, build time is like 1 to 2 days. It takes 1 to 2 days to build that one. PCB color is green. If you want to change this one into red, you can change into red. The price will be same. You can change yellow, whatever color you like, And the dimension is 63 millimeter by 42 millimeter. Layers is 2 layers. And if you want to order, you just need to click over here. Let's try over here. Order data generated finish. Please click OK button and continue. Right. You see Java file, they just, so here is the Java file. They are going to generate this PCB. You can select the color, whatever you like. But I'm not going to order this time. Maybe later in future when I design more complicated PC board. But this one is just like for beginning. So here is everything. Charge details, special offer by covering surface finish, economic. Welcome back, may I help you? This is the client, the customer service. Here I think you need to order. When you confirm this one, then everything will be down. But I'm not going to confirm this one. Do they have any cancel? No. I'm going to just remove this one. Remove this one. It's like $4. That's not expensive, but it's just like $4. So I hope you guys understand the PCB design. Yeah, I like to say sorry because it takes like longer time because I don't have like mouse. Just like using this one, like it takes time sometimes. Thanks for watching. I'm going to stop sharing and maybe later I will come with another PCB design. Bye for now.